All right, I'm gonna go ahead and get started since it is 9. So today we're gonna do the 8.4 that we skipped before spring break. Remember I told you because it was just so long, it was gonna take 2 days. And we did that 5.1 instead, since it was shorter, we could get it all in 1 day. But now we have to do it. Now, this is kind of be going backwards from what we've seen before. Okay, remember when we were finding zeros, what we would do is, let's just say it was a function like this, and we wanted to find the zeros of it or the x or the solutions. We worked this one of 2 ways. We either, since it was quad, went right to our quad program to find the zeros, or this one is factorable. So I could have factored it, x and x for x squared. Factors of 5 that added to 6 would have been a positive 5 and a positive 1, right? That's how you multiply to get 5 and at the same time add to get 6. And then what would I do with these factors? To get to the zeros, I'd set them equal to 0 and solve them for their x's. Okay, which means on this one, I would have subtracted 5 to get x equals -5. And here I would have subtracted 1 to get x equals -1. What we're doing today is they're going to give us the zeros of the polynomial function and ask us to find the polynomial function that those zeros came from. So let's look at this right here. These are the zeros. What factor did this -5 come from? Came from x plus 5. What factor did -1 come from? It came from x plus 1. So let's use that knowledge that if we're given zeros, how to work it backwards. Okay, so let's look at number 1 in 8.4. The zeros, it says, are, there's a polynomial function of degree 3, which means our function at the end is going to start off with x to the 3rd. That's what degree 3 means. Okay, so degree 3 with real coefficients that has the given zeros. The given zeros are -1, 2, and -3. Well, if -1 is a 0, what factor did it come from?
X plus 1.
That's right, x plus 1. If 2 is a 0, it's because it came from x minus 2. And if -3 is a 0, it's because it came from x plus 3. Now, here is where this section gets very tedious, because now I have to multiply all 3 of those factors together to come up with the polynomial function all the way written out. So a lot of foiling. Okay, so if you can do it in any order. My first, if I do this one, x times x gives me x squared. My outer, x times -2 is -2x. My inner, +1 times x is +1x. And my last, +1 times -2 is -2. I can put these 2 terms in the middle together, right? Since they're both x's, they're both like terms, which means they can go in the same basket. So now I have x squared. If I put those together, -2 plus 1 gives me -1x. Bring down the -2. So far all I've done is multiply these 2 factors together. It gave me this. Now I have to multiply. This just drops down. So let's FOIL, or I guess not FOIL because it's not first, outer, inner, last, but I'm going to distribute all of these terms in this parenthesis to the 2 terms in that one. So the x squared goes to both of those. And this is where I'm going to get my degree 3 from, right? X squared times x gives me, there's my x to the 3rd, x squared times positive 3 gives me positive 3 x squared. So I'm done with the x squared. Now I'm moving to this. I'm going to distribute it to both of these. So let's see, negative 1x times x, which is just going to give me a negative, good, x squared, negative 1x times positive 3. So negative 1 times positive 3 is just going to give me a negative 3x. And then the last number I need to distribute is this negative 2 to both of those. So negative 2 times x is negative 2x. Negative 2 times positive 3 is negative 6. Now just clean it up by combining your like terms. This is the only x to the 3rd. But I can put these x squareds together. Let's see, I've got a positive 3 and a negative 1, so my x squareds are positive 2. X squared. Put these together, negative 3 and negative 2 gives me negative 5x, and then bring down the minus 6. So the polynomial function of degree 3 that has these 3 zeros is x cubed plus 2x squared minus 5x minus 6. Okay, now just for fun, let's put that in our y equals and graph it. What does all that mean? What did you just find? If you put this polynomial function in your y equals, so just go to y equals and clear it, put this in. So x to the 3rd plus 2x squared minus 5x minus 6. And graph it. What should happen? Where should it be crossing the x-axis? Negative 1, positive 2, and negative 3. Look at your x-axis. There's your positive 2. There's your negative 1, and there's your negative 3. Those 3 places are the zeros or the x-intercepts of this function. So that's what you just found.
Miss Hanson?
Yeah.
I don't understand what on this formula, right? X cubed plus 3x squared plus x squared minus 3 squared minus 2x minus 6. I don't understand this.
You don't you don't understand where I got this?
Uh-huh.
Did you see me do all of this? I got it by turning all of these numbers, these 3 zeros, I turned them into the factors, which pretty much just means x and then the opposite sign. So
Oh, wait, I think I got it now.
X plus 1, the x minus 2, and the x plus 3.
Oh, wait, I think I got it now. I think I got it now. I was talking about this one right here, like on
did a bunch of distributing.
Okay.
Let's do another one. Number 2 is like it. It adds a little something else, but it's like it. All right, polynomial function in standard form with the zeros are 4, 3i, and negative 3i. Okay, so same thing. I'm going to turn the zeros into the factors that they came from. So let's see, if that's a positive 4, that means it came from x minus 4. Positive 3i just means it came from x minus 3i. And negative 3i because it came from x plus 3i. Now, on the last one, you did it in any order, it didn't matter. However, anytime you have two factors with i's in them, do those first because it's going to clean itself up. And that goes for if you have factors that have i's in them or if you have factors with square roots in them. You want to FOIL those together first. This, you multiply this together with this front one, it's going to give you a big mess. Okay? But if you do these, watch what happens when you FOIL these two together. So my first, x times x squared. My outer, x times positive 3i. I'm going to write that as positive 3. I'm going to actually put the x first because the I is not just a random variable like an x is. An I stands, that's an imaginary part, right? That's what the i's come from. Okay, so that's why I put the I. It actually is not going to matter because look, what's your inner? Negative 3 xi. And then your last, a negative 3i times a positive 3i is a negative 9i squared. Now, look how nicely this cleans up. First of all, what happens to those? They just cancel each other out, right? Because you have a positive 3xi and a negative 3xi. Now, I can't remember if we talked about this in college algebra yet. Anytime you have an I squared is always equal to -1. So this really down here says -9 times -1, which really turns all of this into what? +9. Plain old +9. So all I have left from multiplying those together is the x squared plus 9. Now, I still have that x minus 4 that I have to multiply, okay? But if you would have done these first, all of this nice cleaning up is not going to happen, and you're going to be left with a complete mess to deal with. So again, anytime you have i's, do those first. Now, I'm going to multiply, just FOIL again. X times x squared gives me x to the third. X times +9 gives me +9x.
Miss Hanson, are we on
Yeah.
number 3?
No, we're on number 2.
Oh.
They just take a long time. Wait, shouldn't that be 4? Oh, wait, never mind. Now it will. So now here, my inner -4 x squared, and my last -4 times +9 is -36. I wrote it backwards. So now, if I'm gonna, none of them can combine, but I do need to flip-flop these two terms right here, right? So that my exponents will go down in the right order. So I'm just gonna flip-flop these two terms. So I have x to the third, then -4x squared, then +9x, and then -36. Now, just something FYI, when you are typing this answer in, look at how it has this. You're just putting in missing numbers, and see right here, after it's got x to the third, it's already got the minus there for you. Okay, so that was kind of throwing me off. So it's already got this. So you're actually just filling in that 4, since it's already got the minus there for you. It's kind of tricky. Okay, because you're just filling in missing numbers. All right, let's look at number 3. All right, same thing. Finding the polynomial function, the zeros are square root of 5, negative square root of 5, and 4. So again, if those are your zeros, turn them into the factors that they came from, and then multiply those factors together. So let's see, this one would be x. Did you hear that?
That was loud.
So hard. So here I have x minus the square root of 5. That one will be x plus the square root of 5, and this one will be x minus 4. So again, anytime you have i's or square roots in your factors, FOIL those first because they clean each other up. Okay, the reason they clean each other up so much is they're called conjugates of each other, which means everything's the same except their sign in the middle. So when you FOIL that, those middle two terms after you FOIL are always going to cancel each other out. That's what's going to get rid of your square roots. Okay, so let's go ahead and multiply these first two together. So x times x gives me x squared. My outer x times positive square root of 5. So that's just going to give me positive x square root of 5. Okay, that x is not under your square root, right? It's not under a square root here. So you can't put it under a square root. So you just have, it just hooks them together essentially. Same thing here, except this one's just going to be negative x square root of 5. And then your last negative times positive gives me negative. Now those 5s are both under your square root symbol. So you are going to multiply those 5s together. So what's that going to give me? Negative,
25.
right, square root of 25. What happens to the, like I said, if they're conjugates, they're going to, the middle two are going to cancel each other out. So I'm just left with x squared. Here's what else happens. That's a perfect square, right? What is the same thing as saying the square root of 25? It's just plain 5, isn't it? So this really just says minus 5. So that's why you want to multiply those two together first, because a lot of it cleans up and there's no more square root to deal with. Now I still have the x minus 4 and I'll bring it down and then just FOIL those together. So let's see, x squared times x gives me x to the third. X squared times negative 4 is negative 4x squared. Inner is negative 5x. And last, negative 4 times negative 5 gives me positive 20. And then none of that combines, and it's already in the right order, right? Your exponents go down evenly, or in the right order. All right, let's look at number 4. All right, then the zeros are negative 1/5, 0, and 3. So let's see, this would be x plus 1/5. Now look at this one. It actually comes from x minus 0. But what is x minus 0? It's just
0.
X, right? So remember when we got this as a 0, that's because our factor was just like that. It's just an X, right? So this is just an X. And then this one, don't even look, that's not part of that problem. Came from x minus 3. So there's my three factors. I can multiply them together in any way that I want because there's no square roots and there's no i's. So it doesn't matter what order you do it in. I'm gonna do, because I just think it looks easier. That just means I need to distribute that x. So let's see, that would give me x squared minus 3x. So that took care of multiplying that together. I still have this one, and I just avoided it because it has that fraction. So now I'm going to FOIL that together. So let's see, x to the third. X times negative 3x gives me negative 3x squared. I enter 1/5 times x squared gives me positive 1/5 x squared. And my last, positive 1/5 times negative 3x. Remember, this calculator does all your fraction work for you, right? If you didn't want to multiply that, what do I need to know? I need to know what 1/5 times negative 3 is. So just type that in. How do you type in 1/5? 1 divided by 5. I want to multiply that times negative 3, so I'll just tell it times negative 3. It's going to give me a weird decimal, but just math enter that, right? So if I hit the math button and then I hit enter twice, that's what 1/5 times negative 3 is, negative 3/5.
So you would leave the x out?
No, well, you just can't put the x. Well, I don't know what happens if you put the x.
I did. It just gave me negative 6.
Miss Hanson?
I would leave the x out. Just know in your head that you're going to just do the number part, but it's going to be an x. Yeah, Will?
Yeah, you know, there is another way to get a fraction by multiplying negative 1/5. You just go to alpha and then press F1 and then you
Show me that.
I thought you knew.
Somebody showed me that in a class earlier, actually this semester. I never knew that you could do that. I'm just
Look.
used to doing it the way that I'm doing it, that's easier for me. But yeah, that alpha. Thank you, I learned something new. That alpha way also works. Yeah. I didn't know that either. Now, what else? I need to clean this up, right? Because these are both x squareds, which means I need to put them together. So I'll just bring down the x to the third. Now I can do it now. Just remember, you're putting x squareds together. So I just need to know what negative 3 plus 1/5 is. I can definitely do that in my calculator. So just tell it exactly what you want to know. Negative 3 plus 1/5. So 1 divided by 5. There's your decimal. Math, enter that. So that gives me negative 14/5. Negative 14/5, what? My x squared.
X.
I'm just putting my x squareds together. So negative 14/5 x squareds from putting those together, and then just bring down the minus 3/5 x. All right, number 5. The first part of this problem starts off by saying, find a polynomial function of degree 7. That right there is telling you that this is going to be a long, drawn out, very tedious problem, right? Because we've been doing stuff just be coming up with x to the third, degree 3. And that had a lot of foiling, okay? So let's look at this one. Number 5 says find a polynomial function of degree 7. So instead of coming up with x to the third down there, we're going to start off with x to the 7th. So let's see what that looks like. All right, degree 7 with -1 as a 0 of multiplicity 3. So there's 1 0. 0 as a 0 of multiplicity 3. And 1 as a 0 of multiplicity 1. Now, remember where your multiplicity numbers go. They're the little exponents above the factor, right? That's what the multiplicity number is going to be. So let's see, if -1 is a 0, the factor it came from would have been x plus 1, but this time it's telling me that this factor has multiplicity 3. Zero is a 0. Now remember, this one's not too bad because where does that come from? Just x, right? So if its multiplicity is 3, it's just going to be x cubed. And this last one, let's see, 1 is a 0, which means it came from x minus 1, and its multiplicity is just 1. So I don't even need to see that exponent, right? It's just assumed that it's to the third power. I mean, to the first power. Okay, I don't have any square roots or i's, so I can do this in any order I want. So I'm just going to do this first. I could have done x to the third times that one, but that's a mess. I don't think I would do that. So let's see. What is this going to give me? X to the third times x gives me x to the fourth. Minus x to the third times 1 gives me x to the third. Bring this down. Now, this still has an exponent on the outside of it, which means I need to take care of that. So what does x plus 1 to the third mean?
X plus 1 times 3 times.
X plus 1, x plus 1, x plus 1. So I'm going to do that over here, I think. So let's FOIL this. X times x, x squared. X times 1 is 1x. My inner is another 1x. My last 1 times 1 is 1. So what happens now? I need to clean that up a little bit, right? I need to put the x's in the middle together. So I really have x squared plus 2x plus 1. Drop down that x plus 1. So again, it doesn't seem like we've definitely covered more difficult topics than this. This is just so tedious and long, and one little mistake anywhere, a sign mistake or anything like that is going to throw the whole problem off, right? So I still have to multiply this together. So x squared times x gives me x to the third. X squared times 1, x squared. Distribute the 2x to both of those. So 2x times x is 2x squared. 2x times 1, 2x. And the last part, just distributing this 1. 1 times x is 1x, and the last part, 1 times 1 is 1. Clean it up. Let's see, I've got x to the third. I can put these x squareds together. How many x squareds do you have all together? 1 here and 2 here, so you've got 3x squareds. Put your x's together. Again, 2 here, 1 here, so I've got 3 x's. And bring down that plus 1. All right, you would think that we're getting close, but look what we have to do now. What is this? That took care of this right here, right? So I'm just going to bring that answer over here. And then look what we have. I've got x to the third plus 3x squared plus 3x plus 1. So that took care of x plus 1 to the third. What do I need to drop down? This. X to the fourth minus x to the third. Now what needs to happen? Boil all that. Remember, what degree are we supposed to end up with?
3.
X to the 7th this time. Look what happens with your first. X to the third times x to the fourth. What are you going to do with those exponents since you're multiplying x's together? You're going to add them. There's your x to the 7th. X to the third times negative x to the third. So I've got a positive times a negative, which just makes it negative. Multiplying x's together, which means I'm just going to add those exponents. That's going to give me negative x to the 6th. So I'm done with distributing this. So now I'll move to distribute this. So 3x squared times x to the 4th. What's that going to give me? Positive 3 x to the 6th. Positive 3x squared times negative x to the third. So get your sign right first. Positive 3 times negative 1. So that's going to give me negative 3. What are your x's going to be? Add your exponents. X to the 5th. So I'm done with the 3x squared, distributing it. So just move to the next one. Distributing 3x. Remember, its exponent is a 1, right? So I need to remember that because I'm going to be adding exponents here. What's this going to give me? Positive 3 x to the 5th. And what's this one going to give me? Positive times a negative, so it's going to be negative 3 x4. So I'm done with the 3x. All I have left to distribute is the 1. So 1 times x to the 4th is positive 1 x to the 4th. 1 times negative x to the 3rd. So just minus x to the 3rd. And clean it up. So, any other x to the 7ths?
No.
Nope, just bring it down. Here's my x to the 6th. So I've got negative 1 and positive 3 of them. So how many x to the 6th do I have? Positive 2, right? Well, here's about the only nice thing about this problem. What happens to your x to the 5th? Yeah, so at least that happens. So they just cancel each other out because you got negative 3 and positive 3. So move on to my x to the 4th. I've got negative 3, positive 1. So when I put those together, it gives me negative 2 x to the 4th. And then that's my only x to the 3rd. So minus 1 x to the 3rd, or just minus x to the 3rd. Number 6. This is why I just wasn't mentally prepared to do this the Friday before spring break. To be honest. And I looked at what the next section was. I was like, ooh, let's do that. And this is also
Miss Hanson?
the only sections that we're covering this week are 8-4, 8-5, because
Miss Hanson?
a day and a half. Uh-oh. Well, did you say something?
Yeah. Yeah. How did you get 3x to the 6th power?
Like in the step before this one,
It was part of the foil.
it was part of a foil.
Yeah.
Part of that distributing. Let's do this. Let's do another one. This next one, Will, is just like it. So I'll just go and stop me in the process. If you have a question, I can't remember what I had on here before I erased it. But the next problem is like this one. Yeah. It's not as bad. Because find a polynomial function of degree 4, so that's a little better than degree 7 at least. So it's going to end up as x to the 4th. So let's see, -3 is a 0 of multiplicity 3. So -3 is the 0, and its multiplicity is 3. And 0 is a 0 of multiplicity 1. So this is not quite as bad as number 5.
We're on number 6.
Yep.
It says find a polynomial function of degree 4 with -3.
Yeah, it's going to end up degree 4. It'll end up x to the 4th
Okay.
after I do that multiplying together. Right. Yeah, I see what you're saying.
Gotcha.
So let's see. If this is the 0, what factor did it come from? X
plus 3.
plus 3. Its multiplicity is 3. So its exponent is 3. Now this one's not too bad, right? Multiplicity 1 comes from just x. Now here's what I'm going to do. I'm going to do this first. Because then once I do that and I get what it is after I multiply x plus 3, x plus 3, x plus 3, then all I'm going to have to do is distribute an x to that answer, which just means everybody's going to add an x to their term. So let's do the x plus 3, x plus 3, x plus 3 first. That's what that looks like. And then there's just going to be an x at the end. So once I multiply these 3 things together, then I'll just distribute the x to that answer. So let's see. My first x times x gives me x squared. My outer is positive 3x. My inner is another positive 3x. And my last 3 times 3 is positive 9. Clean it up. Put your x's in the middle together so you really have 6 x's there. So I've got x squared plus 6x plus 9. That took care of those. Now I need to multiply this times x plus 3. If I wanted, I could distribute that x right there. I'm just going to do it at the end. When you're multiplying, you can multiply in any order. So I'm just going to bring down the x plus 3 and the x. So I'm going to multiply these two together. So let's see. X squared times x gives me x to the 3rd. Then I've got x squared times positive 3. So that's just hook your number and letter together, right? Positive 3x squared. I'm done with the x squared. Now I'll distribute this 6x. 6x times x is just 6x squared. 6x times positive 3 is positive 18x.
I know how to multiply, I promise.
Positive 9 times x is positive 9x. Positive 9 times positive 3 is positive 27. Clean it up. There's my only x to the third. Put your squareds together. I've got 3 here and 6 here, so I really have 9x squareds. Put your x's together. I've got 18 here and 9 here. So I've really got 27 x's. Bring down the plus 27. So I've done all of this part. What do I need to multiply this times? That x. Well, here's the good news. If I'm distributing this x to all 4 of those terms, everybody's just going to gain an x, right? Because what's x cubed times x to the first? X to the fourth. So everybody is just going to, all the terms are going to be the same, but they're just going to gain an x. X times x to the third. Let me redirect this. Gives me x to the fourth. X times 9x squared is just going to turn that into positive 9 x to the third. X times 27x. This gives me 27x squared. And x times 27. This gives me 27x. Okay? Now, on number 7 and 8 and 9, it's going to give me a situation and ask where it's going to say find the other 0 or find the other zeros. So before we get into that, remember when we had the zeros, if they had a square root or an I, there was always both of them. There was the positive and the negative of them. That is because when you're dealing with polynomial functions, anytime you have a 0 that's a square root, the opposite of it is also going to be a 0. So if the square root of 2 is a 0, so is negative square root of 2. If 3 plus I is a 0, then so is 3 minus I. So their conjugates are also zeros. So that's all you're going to need to know to work these next few problems. It's actually a little break in this section from this. So on number 7, it says, suppose a polynomial of degree 4 with rational coefficients has the given numbers as zeros, find the other zero. So you have negative 4 is a 0, square root of 2 is a 0, and 9/4 is a 0. So if it says to find the other 0, look what I'm looking for. This doesn't have, it's not a square root or an I. That's not a square root or an I, but this one is. So if positive square root of 2 is a 0, so is negative square root of 2. That's your other 0. That's all you're doing on these. We don't have to multiply these together yet. I know. Number 8, same kind of thing. Suppose you have a polynomial function of degree 4. So it gives me 2 zeros. Well, if I have degree 4, that means I'm going to have 4 zeros. So let's see. My zeros are, the ones it gives me are negative I and 4 minus the square root of 7. So since one's an I and one has a radical like that, That means they're both going to also have their conjugates or their opposites as zeros. So if negative I is a 0, so is positive I. If 4 minus the square root of 7 is a 0, so is 4 plus the square root of 7. So those are your other two zeros. Number 9, last one like this. Another polynomial function of degree 4. Those are the given zeros. So if I'm going to find the other zeros, one's an I, one's a radical, right? Which means the conjugates of those are also zeros. So this one will just be 1 minus 2i, and this one will be 5 minus the square root of 5. Okay, I'm going to try to get number 10 also in, because we really got to start 8.5 on Wednesday also. So I'm going to get number 10 in just to round out the day. All right, find a polynomial function of lowest degree with rational coefficients that has the given numbers as sum of its zeros. So let's see, it tells me negative 2i is a 0, and so is 3. So if negative 2i is a 0, I know also that positive 2i has to be a 0. So now we're going to throw it all together. We've got to now find the polynomial function, which means turn all, just like what we've been doing, turn all those zeros into their factors and then multiply them together. So if these are zeros, this one's factor would have been x plus 2i. This one's would have been x minus 2i. And this one's would have been x minus 3. Right? It tells me those were zeros, which means positive 2i is automatically a 0 also. So that's where the 3 factors are coming from. Remember, if you have i's, FOIL those together first. They'll clean each other up. So let's see, my first, x times x gives me x squared. My outer, x times negative 2i is negative 2xi. My inner, positive 2xi. And my last, positive 2i times negative 2i gives me negative 2i squared. But it does clean up nicely, because what happens to the middle two terms? They cancel. So here I've got x squared. Now remember, I squared is always equal to negative 1. So this really says negative 2 times negative 1, which really makes this x squared plus 2. Bring down the x minus 3. FOIL that together and you'll be done. So x squared times x gives me x to the 3rd. X squared times negative 3 is negative 3. X squared. My inner, positive 2x. And my last, positive 2 times negative 3 is negative 6. Nobody combines. And my exponents are already in descending order. So that's as far as that one goes. So on Wednesday, we will start with number 11. Hang on, don't go. All right. Hines, Barron, Peak, Keys, Climber, Hurst, and 12.
Did you get me?
I got you. Yeah, you were all on the side a little bit.
Thanks.
All right, I got everybody. Okay.